Okay, so we're really close to having our belly setup complete. All we need to do now is automate that secondary motion of the belly jiggle using a jiggle chop. So I'm going to send some data down into the chop network, then we can work with that data and send it back out of the chop network. The data I want to send down is going to be what is currently our IK handle. Just hunt down our belly aim target. Since we know this is going to be modified by both the animation of the spine and the average rotations of the spine and the animation of our belly control, I want to send that down into the chop network. But since this is set up as our end effector, I'm going to duplicate it with Control-C, Control-V, rename this to 2 belly chops. I'm going to use this to actually send the data down into the chop network, and when we bring the data back from chops, I'll then drive our actual aim target with that data. So I'm going to create a new chop network. If I just wait for the tab menu, there we go. Create a new chop network, which I will rename to belly chops. Jump down inside, and I want to bring in the absolute world space position of that 2 belly chops. I'm going to use a channel chop. I'm going to give that the channel name of T, but with a size of 3. If we bring up a motion view, take a look at that channel chop, you can see that we now have a TX, TY, and TZ channel. For the X value, I'm going to use an origin expression relative to the world, since I want the world space position, and I want to grab our 2 belly chops, and it's translate in X. If we accept that, you can see we do indeed get a value. I can copy that. And I want to actually copy the expression, paste that in for Y, and paste that in for Z as well. So that's going to give us an X, Y, and Z value for the absolute world space location of our belly chops, the 2 belly chops null. So now that we have that, we can wire this into a jiggle chop, but we're going to see when we do wire this into a jiggle chop, that currently we get no difference, and that's because we don't have any animation. The jiggle chop works with differences on the channels that are coming into it. Since this is a constant value, the jiggle chop will have no effect. But we can jump back up to the object level. I'm going to apply some very primitive animation to our belly control. So I'm going to key that at frame 1 in its default location, then move forward a few frames and just move that off from that location. Move forward a few more frames and just give that another position. So we have some very primitive animation going on. Fantastic. We can now jump back down inside the belly chops network and take a look at our motion view and see we do have a difference between our jiggle chop and the channels that were originally coming in. There are our channels, and there are the channels from the jiggle chop. You'll see we get some dampening and some overshoot, as well as some resonance after the movement stops as well. So this really does define how that fat on the goblin's stomach should be moving. We should take longer to accelerate and lag behind. It should then overshoot, and we should get resonance. This is going to work really nicely for defining the movement of our belly. Now, it's worth pointing out the parameters on the jiggle chop that are really useful in this case. The stiffness parameter relates to how closely our jiggle values match the values coming into them. As we increase that, you can see we get less overshoot, less lag, and also less resonance. I'm going to undo that back because the default actually works quite nicely in this case. The damping, the larger that value, reduces any oscillating, any resonance that we're getting. So you can see that is going to reduce any of those oscillations, bringing it down. Leaves those oscillations working for a long time. Again, I'm going to undo that. The default here in this case actually works quite nicely. Now we can go ahead and create a null that we can then export this data to. So I'm going to create a new null up at the object level, which I will rename to from belly chops. And then down inside our belly chops network, I can wire our jiggle into an export chop. And the node I want to export to is going to be that from belly chops node. So from belly chops. And the path, we know that we are indeed with channels TX, TY, TZ. I'm just going to export those to TX, TY, TZ. We could of course put star here since they do match up perfectly, but I'm going to manually enter those into the path parameter. If we check the export flag, the third flag along, and take a look at our from belly chops, we can see those values being overridden. which means that this is indeed going to be lagging, and we can see that lag in comparison to the IK handle itself. We can see where the bone was pointing and where our control is definitely lagging. So now we can take that from belly chops and we can use that to drive our IK handle. But before we do, since the jiggle can actually slow down the feedback an animator has, because if that's calculating all the time, every time we move a control object, and that's affecting the position of that control, that's going to be affecting our feedback. So rather than having it always drive the IK handle with the data, we're actually going to, down inside the chop network, break the incoming animation data from our jiggle. We're actually going to take this channel data and bake it out, then load it back in and pass that into the jiggle. That stops the jiggle recooking if the animation upstream changes. And also, the data that's coming out of our chop network, we're going to switch between the non-chops driven data and the chops driven data to give us the ability to bypass the chops data if we want to. And that makes sense, because otherwise we'd end up with a problem where if we didn't simulate the data and update it, the world space location of that belly aim target would never change. And as we start moving our character around in space, we'd find that our belly bone would point back at that same location in space no matter where our character was, because we're not updating that position. So we want to bypass it all the time we're animating. Then when we have the animation in place, we simulate. That will recook the data, it will reload in the data, put it through the jiggle chop. Then we can unbypass now that we have that all simulated, and we can run off the simulated data rather than run off of the old data that was on disk that would obviously be incorrect. So I'm going to branch off of our channel chop into a new null. So I'm going to middle click on the output and wire into a new null. I'm going to rename this to out, all in capitals. Now before I save out the data channels, I want to delete off the animation that we were... Well, actually, let's save it out with the animation, then delete off and repeat this in a second, just so you guys can actually see the bone moving with animation. So I'm going to right click, save out data channels. I'm going to save this into our hip file with the name of belly.bclip. If we accept that and accept, that's going to save out that animation data. I can now create a new file chop. I'm going to leave that named file1, and I'm going to load in that belly.bclip animation data. If we accept that, take a look. We can see indeed that animation data coming from out has been saved and brought back in. We can drive our jiggle with that, and we're still then exporting that animation data back up at the object level. I'm going to create a new blend coming from the two belly chops. I'm going to wire that into a new blend object. I basically want to blend between our two belly chops and our from belly chops, but rather than having a blend where we have floating point changes, I'm actually going to set the blend over to be a sequence. We're either on one or the other. So I'm going to blend two belly chops and from belly chops into that blend. I'm going to rename this to blend. Actually, I'm going to rename it to bypass belly chops, since we're going to use this to either take the animation data before it was sent to chops, or take whatever's coming based on the data that's on disk being loaded back in and wired through that jiggle. So we've got the bypass belly chops. Let's turn off the visibility and selectability of him and the from belly chops. That bypassed belly chops can now become the parent of our belly aim target. So I'm going to, whilst keeping position while parenting, parent our belly aim target into that bypass belly chops. Currently bypass belly chops is set to bypass belly chops, thus if we play, we're not going to have any of the animation being driven by the jiggle, and we can see that because if we come in and take away the animation from that control object, you can see our bone doesn't move. But because we haven't updated the animation on disk, if we set our sequence now over to 1, that's being driven by that jiggle animation, you can see our belly bone moving and having that nice jiggle. And of course, changing the jiggle parameters would allow us to come in and tweak that animation. The jiggle parameters are going to be promoted up to our final character asset to give the animator the ability to come in and tweak the animation along with simulating the animation and controlling this bypass. So now that we've gone ahead and are bypassing, I'm going to switch back to actually bypass the belly chops data and use the control object, and then down inside the belly chops I'm going to right click on our out again, save our data channels and overwrite that belly.bclip with null information, basically, with no animation, no real jiggle animation. But that is going to conclude the setup of our belly control. When we come to set up our asset and actually promote these parameters to our asset, we will drive the sequence, and we will also drive the simulate button and the script to simulate and bake out the animation for us, but we're going to deal with that when we are on our asset itself. So again, we'll drive that sequence parameter and the automation of baking out data and bringing it back in when we come to setting up our asset. So with that, that's going to conclude the creation of all of our belly systems. Thanks a lot.